Good morning. All right, today I'm going to go through the worksheets we did last week on ionic and covalent bonds. So I'm under the chemical systems, then click on classwork, scroll down, week 4. You have them at 2 places. You have day 3 assignment from last week, ionic bonds practice. You can find it there. It's the same assignment as it is right here. Looks like 6 of 11, 6 of 11 by the time that I pop this up. Hopefully everyone who could do it does it. Of course, you're going to get some feedback right here today. So I'm going to click on this. What? All right, let's see what's going on. It happened with me. Could not find preview. Well, let me try clicking on this other one, which you can do as well. So practice. There we go. So it's the same thing. So you can come right back up to that other one because if you recall, you only need to do the first 2 pages, but by the end of the week, we did all of it, 4 pages. So I'm going to work through so you know what the answers are and such. So let me go ahead and open with Cami, and you can do this, or you should do this as well. Okay. So now I'm just going to fill in the number of valence electrons. Okay. I went over this in the other videos and the how-tos. As a matter of fact, I also did the sodium chlorine as an example. So I'm going to skip that one. Okay. You can use a periodic table to figure out the valence electrons for each of these. So go again, all you have to do when you're figuring out these is look to see what group is it in. 1, whoops, actually I'll do a text box here. Is it in group 1, 2, 3? Now remember that between 1 and 2, it skips a few, 3, 4, 5, 6, 7, 8 on a periodic table. And 8 being stable don't interact, and so we don't have any of those here. So whatever vertical group it's in tells you how many valence electrons. So sodium, when you look it up on the periodic table, is in group 1, so it's going to have 1 electron in the periodic table. So we did this last time. So go ahead, if you haven't, make sure you fill all these in now. Again, just hunt on the periodic table, find the element. Once you finally find it, what group is it in? Group 1, 2, 3, 4, 5, 6. Remember, between here is the transitional metals that we're not concerned with. And whatever group it's in, that's how many valence electrons it has to satisfy the octet rule. Okay. So I'm going to go back to our class website and the periodic tables. Remember, I posted a new one that's live, so to speak, dynamic, excuse me. And we'll refer to this one because we can see it better. So again, sodium, it's in the first group, it tells you right there. And you click right back over. Chlorine, when you find it, and chlorine, you can look, and what you're going to find is over here. There's an ionic bond. The whole idea of this practice worksheet is that it's ionic bonds, and you have to remember that the definition of ionic bonds is that it's a non-metal on the right-hand side, in this case green, with a metal, one of these over here, or possibly even one of these two, but generally speaking over here. Okay, so right away when you're looking for these, know that they're going to be on either extreme, the 1, 2, or over here at the 6, 7, most likely. And you need one of each for each of these here. So let's go on to magnesium and iodine. Okay, and let's not forget our steps. So magnesium, I look right there, atomic number 12, group 2, and I look for iodine. Iodine is way over here on this side. You can look, and you'll find it right here, and it's in group 7. Okay, so we got a group 7 with a group 2. So right away, magnesium, whoops, I got to choose this. I'm going to try to draw. Let's go hot pink. All right, so magnesium has 1, 2, and we had the other iodine is 1, 2, 3, 4. Actually, I'm not putting these in any particular order. 5, 6, and 7. And that way we can see that this one needs 1 right here, and magnesium can fill it easily. However, magnesium still has 1 valence electron. So we're going to need another iodine that has 7. And that other one can come and fill this one. And now magnesium has got rid of the 2 extra electrons. Therefore, the energy level below it. Now, what I'm about to write over here, you do not need to write. These are just going to be notes. Okay. So magnesium, remember, if it had an atomic number of 12, okay, atomic number 12, that means it had 2 electrons in that first shell, and it had 8 electrons in that shell, and then it had another 8, 19, 11, 12. And we just lost these outer 2, okay, out here. We lost these 2. And so in losing those 2, it now will have all 8 right over here on the outer shell. Assuming, you know, it's going around it. All 8 are there now. So it's stable, but you lost the 2 electrons. So what we ought to do is have our, now we can fill it 1, 2, 3, 4, 5, 6, 7, 8, but we know it lost 2 electrons. So we're going to have to put a positive 2 over here. Iodine here gained the electron, so it's going to be now iodine, and it's going to be 1, 2, 3, 4, 5, 6, 7, 8 with a negative, and the same thing. And how many iodine do we have? 2. It took 2 iodines to take the electrons from magnesium. This is getting sloppy. Hopefully you can follow. Maybe I'll change my method here in the next example. So just to clear some space. So what's that mean? The formula is going to be, the answer here is going to be magnesium iodine. And how many iodine did we have? 2. Okay, so I'm going to erase this just to clear up some of the mess. But the bottom line is you had magnesium with 2 outer electrons, and you had iodine that needed only 1. So the iodine is only going to take 1 because now it's stable. So you're going to need another iodine to take that other magnesium. These are all chemical formulas for substances that you would probably put together in a lab, right? Just don't randomly find each other in the universe. I mean, they can, but that's not what we're interested in. We're interested in the things that we can control. So if you have 2 bottles, one of iodine, one of magnesium, and you were to mix them together, okay, they're going to come together in this fashion right here, okay? And that would be the final answer. Magnesium iodide. Sodium and oxygen. Sodium, we're starting to remember that it's in the 1 group. Let's find out where oxygen is. It's in the group 6. So how many electrons will oxygen need? We can begin to predict this. It has 6 in the outer, that is valence shell. The other 2 are on the inner. So how many electrons will it need? 2 more. And sodium has how many? 1. Ooh, that's not going to satisfy oxygen. So what's oxygen going to do? It's going to have to find another sodium to pull in that other electron. Let's see how that works out here. All right, so I'm going to try text box here real quick. So we have sodium, and then we have oxygen, right? And these reach a little small, I know, but hopefully still. So sodium has 1. Oxygen has 1, 2, 3, 4, 5, 6. It needs 2 more. All right. So what's going to happen? Well, sodium will give 1 over, but we're going to need another sodium, right? And that sodium is going to have itself one electron, and that electron is going to go where? That's right. That's why I changed my size here to 2. Anyway, and that electron is going to fill the other one. And so you can see now, that's about all you need to do. You rewrite this. Sodium having lost an electron will become sodium positive, and oxygen gaining those electrons will become 1, 2. So oxygen negative. So with 2 sodiums and 2 positive charges and 1 oxygen with its -2 charge, those will attract quite nicely. The charges and attractions will equal out. So the chemical formula is sodium with the little 2, and then oxygen. It only took 1 oxygen, but it took 2 sodium. Whenever the number is small down here, that's referring to the element that came before it, in this case, sodium. If you ever find, this is not the case here, but one day it might be, 2 NaOH, when it's like this, that big 2 that comes in front is referring to this entire molecule, 2 NaOHs. We have 1 sodium to 1 OH. In this quick example, it's just an example. Okay, you have 2 of these things. Whenever the number's in front like this, real big. But whenever it's like this, where you want 2 sodiums, then we put it's a small number down here. Okay, that's the proper way we write it. So that's one of the little lessons that we're learning here. Now I know when you're typing it, that's okay. You might, you don't have a way of making that too small. So I understand that for now, that you'll probably put in A2O, and that would be your answer. Okay. Yeah, that is not correct, because that would tell us what, given my example here? It would tell us that we have 1 sodium and 2 oxygen, and that's not correct. So we need to have that the proper way. And there is ways to do it on like a Word document, but we're not going to concern ourselves with that. We're not getting so far into it that we're going to have to distinguish these. So just having it typed like this, I will accept it. Or if you handwrite it like I am, then you'll do it like that. Na2, big O. All right. Let's skip ahead. Let's do maybe this. Let's see, which other one might you have a question on? Well, actually, what I'm going to do probably at this point is just give you the 2 answers for these. Just in case there's some of you that haven't had a chance to do it yet, I want you to be able to show me your work here. But at least you'll be able to, after this, check your work to see that you've done it correctly. And you'll have the answers now. Okay, so calcium and chlorine. What I'm going to do is at least go to calcium. I see it's in group 2. Chlorine is in group 7. With a group 2 and a 7, that means chlorine needs only 1, and calcium has 2. So because calcium has 2 to give, we only need 1 calcium, and chlorine needs only 1. We're going to have 2 chlorine to take the 2 from calcium. So CaCl2 is the answer to that one. You might have to rewind and listen to that one again. Whoops, I should have wrote that here. My bad. So calcium has a positive 2, will have a positive 2, and chlorine will have a -1. Therefore, you're going to need 2 chlorines to bind with the 1 calcium. Magnesium, aluminum chloride. Again, I'm going to come back here. Aluminum chloride. So there's aluminium and chlorine. Now, this is weird. It feels weird because it's way over here, but remember, group 3 only has 3 electrons. It needs 8. So it is more like these metals in that it's easier to let go of 3 than it is to pull in, 5. So there's aluminum, group 3. Chlorine, we still have group 7, so it needs only 1. So we come over here, aluminum and chlorine. If chlorine, once it gains it, will be a -1. And aluminum, once they lose them, will be what? How many did it have to lose? It was in group 3, so it's going to lose 3. So it's going to become a positive 3. So what's that going to be? One aluminum donates 3 electrons. You can see the pattern here. It's going to be chlorine 3. AlCl3, that's the answer. Last one for the ionic bonds, and I'll stop this video and I'll make a separate one for the covalent bonds. All right, magnesium plus oxygen, the answer you should have got. If I know magnesium, here's in the 2 group, and oxygen is in the 6 group, if you recall, it's over here, group 6. So this one needs 2, this one has 2. This is one of those easy ones again, because once magnesium loses those 2, it becomes positive 2, and once oxygen gains 2, because it needs them, it's going to be a negative 2, excuse me, sorry about that. It's going to be a negative 2. Well, that's a 1-to-1 ratio, right? That's an equal and opposite attraction. So it's only going to require 1 magnesium per oxygen, 1 oxygen per magnesium. And there you go. Now, I just want to be clear real quick that I did not show the work on these right here. I'm just giving you the answers, showing you that there is a quick way to find chemical formulas to these elements. But the purpose of this is to go through to realize the valence shells and how electrons transfer to a new element. And then I want you to write the charges of those ions, because any charged particle is called an ion, and then the resulting formula. Okay, so you go through the motions and you can check your answers with these. There's the calcium chloride, aluminum chloride, and magnesium oxide. Okay. All right, well, I'm going to stop here, and I'll do a separate one for the covalent bonds.